the car is increasing 2 hours later. That's the trap. Increasing when? At the moment such and such, at the instant such and such. This is a trap. So the two cars are going like this. They start here, and one is faster, and the other one's slower. So at some point in time, this is the distance between them. This one. So I'm going to call this W. So let's read the question again. At what rate is the distance between them increasing 2 hours later? So I need something when time equals 2 hours, but I don't know what this is. I need to know what I'm looking for. If I can't identify this, then I don't. Say it again.
Wouldn't it be dy over dx?
Y does not depend on x. They are completely independent. I'm going south, you're going west. There is no relationship between x and y in that way.
I was just thinking because it looks like the slope of a line, which would be y over x.
But let's read the question one more time. At what rate is the distance between the cars increasing 2 hours later?
So that dw over d?
dw over dt is what we are asked to find, the rate of change of the distance between those two cars. Awesome. Great job. So therefore, I'm sure you understand that this is a 90-degree angle, and I know that you know that this is a right triangle. There is a famous relationship that we apply in all right triangles, and it bears his name. Yes. How do I write it for this particular situation? How do I write it for this?
I'm looking at it. We have two sides and an angle.
Right. So whatever you tell me, I'll write it.
It will be the square root of 60
No square roots. No square roots. No square roots. Directly the Pythagorean theorem first.
25 squared plus 60 squared equals w squared.
25 is the rate of change of x. We haven't gotten to that.
Okay, that's what I was thinking too.
Is it dx over dt squared?
I have
just x squared plus y squared equals w squared?
This is the Pythagorean theorem.
Mm-hmm.
The Pythagorean theorem has nothing to do with rates of change. The Pythagorean theorem says the sum of the squared legs equals the hypotenuse squared. The sum of the two legs squared equals the hypotenuse squared. That's all what Pythagoras says. Awesome. Now I'm going to put a little dot under all three. Why am I writing a little dot under all three? Why do I need to put a little dot under these three letters? To remind myself what?
To differentiate?
Yes, but to remind myself that they are all
derivatives,
functions
of
Time.
all are functions of time. This changes with time, this changes with time, this changes with time. Awesome. Now we are differentiating. Yes, I'm ready. We differentiate this, knowing that x is a function of time. Awesome. How do I write it?
2x times dx over dt.
Excellent. Plus
2y times dy over dt.
excellent.
2w over 9 times dw.
I'll simplify both sides by 2. Each term was divided by 2. I am after this when t is 2. I have to solve for dw first, dw over dt, and then plug in everything I have. That's it. Awesome. Thank you. And I am on page 4. So dw over dt equals x dx over dt plus y dy over dt divided by w. And now, yes, when time is 2 hours. I have a formula for w over dt. It's this. Now I can plug in numbers. And let's see what numbers I can plug in. This is given to us 25. This is given to us 60. I have to determine this. I have to determine this. And I have to determine this. This is clear. It's exactly what Evelyn wanted to say. She said the square root of x squared plus y squared. That's the w. But I don't have x, I don't have y, I don't have x, I don't have y. Well, I do. So now, keeping in mind that time is 2 hours, can anyone tell us how much is x when time is 2 hours?
50.
Yes,
Times power.
rate times time. 25 times 2. Exactly. This is 50. So this will be 50 squared. When time is 2 hours, can anyone tell us what this will be? How much?
120.
120. Very good. So this is 120. And this will be 120 squared. So finally, we have all numbers we needed. So dw over dt is 50 times 25 plus 120 times 60 over the square root of 50 squared plus 120 squared. You have to be very careful entering this in the graphing calculator, please. So let's do that. Okay. So parentheses for the top. 50 times 25 plus 120 times 60, close, divide by the square root. I don't know what kind of calculator you have, so but I would always put parentheses. 50 squared plus 120 squared, close, close, and outside. Enter. 65. So dw over dt is 65. Measurement unit.
That be miles per hour?
Absolutely, thank you. The rate of distance, change of distance with respect to time. This is distance, this is time. Perfect. Well done.
Don't move us yet, please. One moment. I'm copying.
Sure. Also remember, I post this. I know you're gonna look. I know you're serious, so. Okay, so let's look at other examples. Any questions? Any questions on how we determine 50 and 120? So distance equals rate times time. for uniform motion, you can say that's impossible. I would have to agree with you. I can't start at 60 miles an hour. So it cannot be uniform motion. We assume uniform motion. But it's not possible. I have to start from 0 and get to 60, which is not uniform motion. But we assume that. Okay, so let's continue. Where is my book? Here it is. We already did the spotlight. Yeah, this is interesting. Let's look at 21. If you have preferences, please choose. So 21. The altitude of a triangle is increasing at a rate of 1 centimeter per minute. This is what I have from the first sentence. The altitude of a triangle is increasing, so it's positive, at 1 centimeter per minute. What is given to us in this first sentence? I have to dissect the problem piece by piece.
Is that like dh over dp?
Perfect. Awesome. Now I can read on. Oh, I'm sorry, Evelyn, are you okay? Did you need more time?
No, I got it. Thank you.
Thank
I
you.
got it.
While the area of the triangle is increasing at a rate of 2 centimeters squared per minute.
That's just like dA over dp.
Of course, thank you so much. Good. So this is what we got from the first sentence. At what rate is the base of the triangle changing? When? You know that this is the trap. That's where it starts. With when? When the altitude is 10 centimeters and the area is 100. At what rate is the base of the triangle changing? When the altitude is 10 and the area is 100. How fast is the base of the triangle increasing? When, and that's the trap, when the altitude is and the area is. What are we asked to find? If we can't identify what we're asked, then we're stuck. Can anyone unglue us? Let's
dh over dp.
So let's read the question again. That's okay. We always have to read more than once. At what rate is the base of the triangle changing when the altitude is and the area is?
Oh, that would be dB over.
Exactly. Perfect. Anyone remembers a relationship between area, height, and base for a triangle?
Half base times height.
Yes. So area equals 1/2 times the base. I have to use the same letter. Times the base times the height. Awesome. I'm going to put a little dot under these 3 variables. I shouldn't say variables. These 3 letters. Why am I putting a dot under those 3 variables? Letters.
They're all functions of time.
They're all functions of time. When this changes, and then the area changes as well. Awesome. Okay then, so we are differentiating. The left-hand side.
That's dA over dt.
Excellent. 1/2 is 1/2. What procedure or formula I have to use here?
You can product rule.
Product rule, please, thank you. Perfect. We differentiate b. Well, it's dB over dt times the second function plus the first function times the second function prime. Now, see what the variable is? Only this. This is what I have to solve for. I will distribute 1/2, move this term, and divide by 1/2 times h. So first let's distribute. So I have dA over dt equals 1/2 h times dB over dt plus b over 2 dH over dt. This is the variable. So I'm solving for it. So dB over dt equals. Maybe I should write one more step. Or not, you tell me. So it's dA over dt minus b over 2 dH over dt. This goes next to this one. It was positive, now it's negative. Everything divided by 1/2 h. And now I can plug in 10 and I can plug in 100. So let's stop for a moment and see if you have any questions. Any questions till this point? Any questions?
Wait, why is the 1/2 h on the bottom?
Because it multiplies the variable. So I have to divide by it.
Oh yeah.
So this goes here, dA over dt minus this.
Oh, I see. You just walk where dB was. Okay.
Yes, and I divide by whatever multiplies dB over dt. Is that better?
Yeah.
Okay, so now I can plug in my numbers. dA over dt is 2. B, I don't have, we'll have to determine it in a minute. dH over dt, they're giving us it's 1. H, they're giving us is 10. So I have to find B. From this relationship, I have to find B. So the area equals 1/2 times B times H. I have the area to be 100 times B, and H is times 10. I'll simplify, and when I divide both sides by 5, I get that B equals 20. So now I have all the numbers I need. So 2 minus 20 times 1 is 20, divided by 2 is 10. And then 10 divided by 2 is 5. So this is negative 8 over 5. Measurement unit. So let's go back. At what rate is the base of the triangle changing? They're not telling us if it's positive or negative. We got a negative answer. Fine. When the altitude is 10 and the area is 100. Measurement unit. And this is the base of the triangle with respect to time. Measurement unit. All these were in centimeters and centimeters squared. I need to identify the measurement unit here. And you can write it as negative 1.4.
Centimeters per minute.
1.6, sorry. Centimeters per, it was per minute, yes. So, yeah. What am I doing? How much is 8 divided by 5? So it's 1.
I think you have it right. Yeah, it's 1/6.
Okay,
And 1.6.
perfect. Okay. It's good to not to trust. I'm okay when I don't trust and I check. Good. Any questions on this problem? Okay. Let's look at one more, and then I would like to present 3.10, and then we'll come back to on Wednesday. We're going to review and review and review.